Hello and welcome to 8.1b. This is going to be moon phases and eclipse. So we're going to start with moon phases. And over the course of a month, and as I put month in there because it used to be based on this 29.5 days, but of course that doesn't round out very well with 365, so we actually changed them to 30 and 31 days to make it work, and then with a 28-day February, except for every 4 years for that 365 and a quarter. Actually, it's 0.427. We actually have to add a day in February, unless, of course, the year ends with that 2000s, then we skip it. And then, of course, if it's by 10,000, then we add it again. It's crazy, but our calendars work. Okay, we have 360 degrees of revolution in 23 or 27 and a third days, but we actually have moon phases based on 25 and a half days. And this is because of sun references and star references. So here's a diagram I'd like you to draw. We have new moon lining up. So we have the sun, the moon, the earth. I'm going to call this one day 0. And as it actually moves across through here, we rotate or revolve one whole time around to this point, and that's 27 and a third days. That's in reference to a star. So if we go up past the sun and we see a star way over here, we're going to point to that star again in 27.3 days if we were on the Earth looking at the moon. And it takes an additional 2.2 days for the moon to catch up, so that it actually catches up what's called a Sidonic month. Okay, and that's based on the sun. So we're pointed toward the sun here and a star. We're pointed toward just the star here, 27 and a third days for 360 degrees, and we have to go an additional 2.2 days so we can line up back with the sun, and that's called a Sidonic month versus a sidereal month. Each phase will be shown on the following slides, and we're also going to have days in the cycle that it appears, and I'd like you to draw each phase as well as write out the date or the days and the name that's shown, including prefixes like waxing and waning. So here's the new moon. I'd like you to draw that. You can even just draw a circle and color the whole thing in, sort of like this. Moon is in front of the sun, and the far side receives all the sunlight, and this is day 0. It's actually day 29, 0, and 1, so it lasts about 3 days. And there is something called earthshine, so if we get too close to this 20, almost 29, or a little past the 1, we start seeing a little bit of the moon on both sides. But what's happening is the sun is actually on the other side. This is a fully daytime moon, and the moon's actually, or the light from the sun is hitting the earth, and some of that light's bouncing back and hitting the moon, and then coming back. So we actually get what's called earthshine, and that's what this picture is too. Of course, it's through binoculars, so a little easier to see. Then we have what's called the waxing, and remember this, if you have the right side on the bright, we have a waxing crescent, and notice the beautiful resolution you can see close to this limb. Beautiful craters, a little tougher to see over there, but real easy to see really close to this limb. And you can draw something like this. Remember that the Earth moves around the sun counterclockwise, the sun spins counterclockwise, the moon moves around the Earth counterclockwise, and it tends to orbit. Remember, it's a synchronous orbit. It actually orbits counterclockwise as it moves around. So here's an example of a crescent moon. This is the moon is backlit by the sun. It approaches 1/4 of the cycle completed, and this is going to happen on days 2 through 6. So we actually get about a 5-day, 2, 3, 4, 5, 6. We get a 5-day period where the crescent starts out really small and then gets almost to the quarter. Then we have the first quarter, or the waxing quarter. Quarter moon is saying that the cycle is 1/4 of the way through. The name indicates the portion of the cycle completed. It doesn't say that the quarter of the moon is lit up, because that's really half the moon. And again, look at that nice, beautiful resolution next to the limb, where the craters that were over here are a little harder to see, and the craters over here are really hard to see. And you can draw something like this. And this happens on day 7.4. Then we have the waxing gibbous, where it's almost totally lit up. Again, it's the right side is bright, and again, you can see really beautiful definition of craters on the limb. Not so much in other places, unless, of course, you've got these rays that point to it. I'd like you to draw a moon that sort of looks like this. This is where the moon is getting brighter and brighter as it approaches the full moon, and this happens between days 8 through 13. Then we get the full moon. This is halfway through the cycle. The entire lit side is facing the Earth, so if they were looking at the Earth from the moon, we would actually have a new Earth because the sun is behind us. And you could draw something like this. Remember, I'd like you to really draw a face, saying that you didn't forget to draw some color. You actually meant to leave it completely open. Then we have the waning gibbous, and the right side is not bright. So it's the left side that's bright. That doesn't rhyme. Right side bright, meaning waxing rhymes. This one does not rhyme. Again, beautiful denotation. This would be sort of like the crescent moon, except the crescent now is dark. Moon starts to darken again. It's over halfway through its cycle. This happens day 15 to 21. Then we get to the last quarter, and again, this is actually showing you that you are 75% through the cycle, which makes it the last quarter, and it's headed toward the crescent. Beautiful denotation right around the limb. This happens at day 22.1. Waning crescent, moon's almost completely dark again. Beautiful resolution really close to the limb, and it's actually headed toward almost being in between the sun and the earth again for the new moon. This happens days 23 through 28. Remember, 29 and a half days, getting really close. Then we have the new moon. Again, this is 29 and a half for the new moon. The cycle both ends here and also begins because we're going to get close to that waxing crescent over there again. And remember, the luna's lunacy just keeps going over and over and over. I'd like you to draw this diagram. Take a look at it. Sun's coming in from this picture from space. These lines don't change, but standing on the Earth, where we see it completely dark, a little bit lit, right side for waxing, first quarter of the way through, almost approaching a full for a gibbous, waxing gibbous, full moon, waning gibbous, starting to get dark on the right side, and it gets smaller and smaller, 75% through, almost back, and back to the new moon 29 and a half days later. We do have what's called the Earth-Moon barycenter. The point of revolution is that point right there, and because the moon actually tugs on the Earth, it actually moves in a wobbly type fashion. That's what you see with this red line, and you can see that the Earth wobbles, and it wobbles more when we actually get apogee or perigee. So if we're close to it, we wobble less. If it's closer to it, it's going to pull the Earth closer to. So we probably have a far moon in there that wobbles the Earth more, but you can see it just wobbles back and forth all the way through the year. And then we have a new moon. We have a spring tide at this location. And then we have the first quarter neap tide, and then we have a full moon. And then we have another neap tide where they get closer and closer together. And you can see where they have a new moon or a full moon versus a third quarter or a first quarter moon. Then those locations all the way around the year. Okay, this is going to be a shock wave, and what I'm going to do here is I'm going to drag. You can see this is a new moon. It's actually showing that the sun is located right there and the moon's located right there. And what I'm going to do is I'm going to drag this in a counterclockwise direction, and you can see I've got the illumination, and I'm going to day, what was the date for the, okay, 2 through 6. So here we still have the crescent, or the new moon, and then we get to this point, we start saying it's a crescent, and it's a crescent until we get to about there. And then we're going to move to 7.4. Should be 2.5, something right about there. And then we actually have the quarter moon, and then we move over 8 to 21. Can't be days 15 through 21. It's probably days 8 through 11. So change those dates back for the waxing gibbous from 9 to 11. And then we get to 14 point, oh, I'm looking at the wrong one. Okay, it's 8 to 13. So this ends the gibbous, and then we go from there to 14.8, which puts it at 16. So there's the full moon, and then we move over to a waning gibbous, last quarter, waning crescent, and then all the way back to a new moon. You can get that shock wave by going to this location. Okay, and have you ever heard of something called a blue moon? Once in a blue moon especially, and again, this is a picture of the full moon. It's tilted a little off center, but it's an artistic view of a blue moon. Blue moon actually is a real phenomenon. It happens when we actually get 13 full moons in a year. And this means that if we get 13 in a full year, we may actually get a month with 2 full moons. And that second of the 2 is called the blue moon. The next blue moon we're going to have is going to be on January 31st, 2018. We don't have any at all in 2017, and I'll show you a moon. Actually, I'll show you this map right here. And if you take a look, the next one we're going to have is the 18th. It's going to be January 2nd, and then March we'll have another one, then October, and then that's actually 2020, and then 23. This all goes to 2039. So you can see it doesn't happen very often. And looks like we'll have a full moon on the 2nd, and we'll also have a full moon on the 31st, and that'll be our full moon. Okay, so let's go back to, that's not what I wanted. Let's go back to here. And here's the 2017 moon calendar, and you can see that we don't have really any full moons all the way through December, and that's why we're going to have one in January, because it's really close on the 31st of December. And that means we'll have 2 of them on a month with 31. And of course, it's a lot easier to have these for 29.5 days if we have 31 days in the calendar. Okay, the solar and the lunar eclipse, 2 types. So I would like you to diagram these, or I'd like you to draw these ray diagrams, where we take the top of the sun to the bottom of the moon, and the top of the sun to the top of the moon, and the bottom of the sun to the bottom of the moon, and the bottom of the sun to the top of the moon, and we actually show the extent of the umbra and the penumbra. And this is actually not to scale because it would not be this big, but basically this is the way we get it, is we get a totally blocked out section which is up to 70 miles wide, and that's assuming a very close Earth and a very far sun. And then this is what it would look like if we get a perfectly covered, actually we see a little bit of sun out here, but we're getting almost a perfectly covered moon, and the sun is 400 times farther or bigger, but it's also 400 times farther away, and this is 400 times smaller and also a lot closer. And then we also have what's called a lunar eclipse. This is a blood moon, and that happens when the sunlight, the only sunlight that's hitting this moon is sunlight that actually bends around the Earth. This reddish color atmosphere we see with a very low sun hitting the moon and bouncing back. But again, top to the bottom, top to the top, bottom to the top, bottom to the bottom. We have an umbra, much larger, and so we actually have about 7.5 minutes of totality at the absolute most. The one that's going to happen on August 21, 2017 is only going to give up to about 2 minutes and 41 seconds. So we're actually getting a much farther, probably a much farther sun and a much farther moon, so much smaller shadow, about as small as you can get. But it's the best solar eclipse and the only total one we've had since 1979, and it won't be, the next one we're going to get will be much later, and I'll show you a map that will actually point that one out as well. So again, you're drawing these two ray diagrams. Okay, so here is a picture of the sun's shadow, excuse me, the moon's shadow in the sun, and you can see that dark part is very small, and even the umbra is not very big. So a very small portion of the Earth actually gets to see a solar eclipse when it comes through, and the umbra path up to about 70 miles wide. Okay, so here's the August 21st, 2017 eclipse, and you can see it starts out in the Pacific Ocean, ends out in the Atlantic Ocean. Here's the next one. It's going to be in April 8th, 2024. This one is the 2017 is closer to Virginia. This is going to show, this is one looks like it's going to be a lot thicker. And you can see this one in August 2027 is probably a much thicker one. So we've got a much closer moon or a much farther sun. And you can see when we actually get really close to the poles, because of the extent of exaggeration on these maps, it gets much, much thicker up here, and it's much thinner at the equator. But this means we probably have a much thinner eclipse of totality. Okay, so here's going to be one. Let me go back. Well, let me just play it through. So if you take a look at the time, Eastern Daylight Savings Time, because this is going to be in August, this is 12 noon, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock. So here it comes. And if you take a look, we're going to be located over here. And you start seeing that somewhere around 1:30-ish. And then our maximum is going to be probably really close to 3 o'clock. And I'll actually show you this. Vimo can't see this at school, but I'll show you this map or this movie. And we'll go full screen. Okay, here's Virginia, and if you watch it, we've got a total sun, and you can see we're going to have the best eclipse over here in the southwestern Virginia, where 97% of the moon will be covered. Up here where we are, Manassas, 82%. So we're going to be maybe a little better than that because we're closer to the 83. But you can see as the shadow moves through, the best part of Virginia is going to be down here. But you definitely want to get some eye protection if you want to watch this eclipse. If you want to watch this link, you can click this and actually see it. And you see it's coming from Shadow Substance /2017/2017e.swf, so it will not work on your devices. Lunar eclipse works like this, and I showed you a video or animation of the eclipse we had just this past Friday, where we had a penumbral eclipse. But you can have a penumbral, you can have a partial if it touches the umbra, you have a total if it's completely in the umbra, and you have a penumbral if it just enters the penumbra and doesn't touch the umbra. This is one back on April 4th, 2015, and I'm not sure who got to see this one, because I don't remember that exact date, but it was a pretty decent eclipse because it got to the blood moon. And again, it's blood because the only light that hits it is the stuff that goes through our atmosphere, it bends, and it's red. Okay, that's it. Thanks for stopping by. Adios.